All right. How's it going, everyone? Thanks, of course, for watching this video. Make sure to hit the like button under the video. That would be awesome. Anyway, this video, of course, is looking at dividing fractions. And of course, as you see on your screen, we have our Common Core Standard NC5NF7. That, of course, is the North Carolina Common Core Standard for 5th grade, looking at dividing fractions. All right. Do take note as well, as I've said in previous videos. Make sure to pause this video so you can copy down any information as well as solving certain problems. So let's go ahead and dive right in. Some key notes and some key ideas that we should know when it comes to dividing fractions. If, of course, your first number or the second number is a whole number, you must turn it into an improper fraction. And how you do that, you simply put a 1 under the whole number, like so. So there we see a whole number of 4. In order to turn that into a fraction, we get 4 over 1. Now, when dividing fractions, if you do not use a visual, it definitely is easier to remember that you need a fraction divided by a fraction. Now, some teachers, of course, may use a rule that's called KCF. No, not KFC. All right, we're not here talking about chicken, but it's KCF. All right, and what that means is it's keep, change, flip. That means you keep the first number. You do not change it. You just leave it alone. You change your division sign to a multiplication sign, and then you flip the second number, which means the numerator becomes your denominator and the denominator becomes your numerator. That, therefore, mathematically is known as the reciprocal. You're using the reciprocal. It's a flipped number. The reciprocal, then, is also the reversed number. So, that being said, here we have 4 over 1. The reciprocal of that would then equal 1 over 4. So again, notice how we reverse the number. Numerator became your denominator, denominator became your numerator. That's the reciprocal. All right, so let's take a look. If we were to use a visual, right? Let's say we had 1/3 being divided by 4. How would that look as a visual? Well, here's one way. Of course, you can start with drawing a square. So you start with a hole. We were going to call that square a hole. Then you're going to split the hole into 3 pieces. Again, we're looking at 1/3. So it needs 3 equal pieces. And you're going to fill in one section, 1 out of 3. And now therefore you can see the size that you have 1/3. Then you split the 1/3 into 4 equal groups. Again, you're dividing 1/3 by 4. So you're going to split the third into 4 equal groups. Therefore, this shows the size of each piece. And you, of course, can draw the line straight down. And what's going to end up happening, to figure out the size of each piece, to compare it to the whole, you split the whole into 4 groups. So therefore, each piece then, if you were to count in that entire whole, we have separated, you have 1/12. Each is 1 out of 12 pieces. So 1/3 divided by 4 equals 1/12. All right, so now here's an opportunity for you to try this out on your own. So pause this video after I give a few instructions so that way you're able to solve it and see what you come up with, okay? So here, I want you to divide 1/3 divided by 2. Try that out. Based upon what we just saw using a visual, how would that look? So pause this video and try it now. All right, hopefully you were able to try it out and see 1/3 divided by 2. So just like we saw before, we have one whole. That's what you're going to start with. Then you divide it into thirds, right? And you see going across making rows, we have thirds. And then you're going to divide those thirds into 2 equal columns. And then how many total pieces would you have? So one piece would then equal 1/6. And if you count there how many small squares you have 6 small squares. Each of them are 1 out of 6. So 1/3 divided by 2 is 1/6. All right, so now let's take another look. How can we use that? Now we looked at a visual, but how else can we do that with using the rule? So 1/3 divided by 2. We already know that it equals 1/6. So how else can we represent that? Well, remember, when dividing fractions, if you do not use a visual, it's easier to know and to have a fraction divided by a fraction. So 1/3 divided by 2, we're going to keep, change, flip. So we're going to keep the first number, change our sign, and we're going to flip the 2, which is 2 over 1. So remember what I said, keep, change, flip, right? So we've got to find the reciprocal. So 1/3 divided by 2 over 1. 1/3 stays, change your sign, and the 2 over 1 becomes 1 over 2. And notice, your division of fractions has now become multiplication of fractions. You're basically doing the reverse. Well, that's good to know because the reciprocal is what you're using. So now we have 1/3 times 1/2, or 1/2 basically. So numerator times numerator is 1. Denominator times denominator is, of course, 6. And we get our answer of 1/6. Now, if you recall in previous videos, you needed a common denominator when it came to adding and subtracting fractions. That's the only time you need a common denominator. When it comes to dividing or even multiplying fractions, you basically just go straight across. Denominator times denominator, numerator times denominator, so on and so forth. All right, so again, that's looking at the rule. You keep the first number, whatever it may be, change your sign, and flip. You find the reciprocal of your second number. All right, so now I want you to try this one out. So I want you to try and solve 1/2 divided by 7. So pause this video now and see if you can solve this problem. Hopefully you're able to solve this problem. 1/2 divided by 7. Well, how would we do that? All right, so remember, you keep, good job, your first number. So 1/2. C stands for change. Good. Hopefully you were able to say that. And again, it's not KFC. That's a fried chicken place. We're looking at keep, change, flip, KCF. So you change your sign, division sign, to a multiplication sign. Now, I want to pause right here for a second. Notice that that is not an X. Sometimes we see multiplications, or rather, most times we see multiplication with an X. So number times another number, and number X, another number. As you go through math, different grades, you'll also notice other ways that you can use multiplication. And this right here is another way, using a dot. That dot also represents multiplication as well in between the numbers. Notice it's not low, because if it was low and if it was a whole number, it might be represented as a decimal. So it's kind of like right in between. But again, just take note of that. There's other ways you can use multiplication instead of just an X. So it's 1/2, and then we have the dot. So you're going to change division to multiplication. And we're going to flip. Well, remember, if it was 7, and that's a whole number, we would represent that as 7 over 1. So we flip that, and it becomes 1 over 7. So now you solve this problem. 1/2 times 1/7, and hopefully you got 1/14 as your answer. So going back, 1/2 divided by 7 is 1/14. All right. So remember this. If the first number or the second number is a whole number, you must turn it into an improper fraction by putting a, good job, a 1 under it, like so. So 4 would then equal 4 over 1. When dividing fractions, if you do not use a visual, it'll be easier if you have a fraction divided by a fraction. You need to have a fraction there. Okay? And don't forget the rule as stated. Teachers sometimes use the rule keep, change, flip, right? They may call it something else, but knowing that you leave the first number, change your sign, and then you find the reciprocal of the second number. So again, here we have 3 divided by 1/3. So what would that look like? 3 over 1, change your sign, and flip, it would be 3 over 1. So now we have 3 over 1 times 3 over 1. That, of course, would equal 9 over 1. Now, you can't leave it like that. That would then, again, look at a fraction as a way of division. 9 divided by 1, and that would, of course, equal 9. All right. Now I want you to try. Try this. 6 divided by 1/7. A whole number divided by a 7. So pause this video and see what you come up with. All right. Hopefully you were able to pause this video. 6 divided by 1/7. What did you get as an answer? Well, remember, you keep the first number. So if that's a whole number, what do you put under it? Hopefully you said a 1, because then you're absolutely right. You turn it into an improper fraction, 6 over 1. You change your sign, and then you flip, or you use a reciprocal. 1/7 becomes 7 over 1. So now we have 6 over 1 times 7 over 1. That equals 42 over 1. Again, you have to change that. You can't leave it like that because it's improper. You must make it proper. So 42 divided by 1 equals 42. So hopefully you got that. 6 divided by 1/7 equals 42. Now, I want you to think about this for a second. Did you notice something? When you had a fraction divided by a whole number, you got a fraction. And then when you had a whole number divided by a fraction, you got a whole number. So I want you to think about this for a second. Okay? What this basically means is your fraction that you get, when you have a fraction divided by a whole number, you end up getting a smaller fraction. When you have a whole number divided by a fraction, you get a larger whole number. And what that means, that larger whole number, that's how many thirds you basically have. Okay? All right. So now let's use a visual, another visual. Here we have this type of problem. Using a visual now with a whole number being divided by a fraction. Before we saw using a visual with a fraction divided by a whole number. So let's see. 6 divided by half. That's the same as saying how many halves are there in 6 wholes. So here you can see the first part where it says 1 whole. I have 6 of them. And then what I did, they're separated by half. So how many halves do you see there? We'll count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 halves in 6 wholes. So now try this out. Using a visual, we have 5 divided by 1/3. How would that look? So I want you to pause this video and try that now. How would that look? 5 divided by 1/3. Hopefully you were able to, of course, pause the video and try this out. 5 divided by 1/3. How many 1/3s would we have in 5 wholes? So if you have something like that, you're off to a great start. So we have 5 wholes there. We need to separate that by thirds. And think, that is the same as saying how many thirds are there in 5 wholes. So if you have that, again, you're off to a great start. This is now using a visual, as I said. So then you just count them, and you should have 15. There are 15 thirds in 5 wholes. 15 thirds. Awesome. All right. Here's a word problem now. Let's check this one out. Oliver used 1/4 of a cup of sugar to make a pitcher of lemonade. That sounds really good right about now, right? Anyway, if he were to pour the lemonade into 3 smaller glasses, how much sugar would be in each glass? Now, again, as I've said before in previous videos, when working with word problems, let's say on a computer, I know many are familiar with using cubes. You circle your number, underline your question, box key mathematical words. E stands for evaluate, which means to think. You think about the problem, and then finally you solve, right? Well, in this case, since it's kind of hard to really do it on the computer, you can still break up the question and really think about what they're asking. So, one way of looking at that. I'm going to read it one more time, and then we're going to break it down. Oliver used 1/4 of a cup of sugar to make a pitcher of lemonade. If he were to pour the lemonade into 3 smaller glasses, how much sugar would be in each glass? So, here's a great way of taking information out and really making sense of this word problem. Because what I used to even tell students is it has to make sense. Your answer that you get as the end of the problem, it must make sense. So we have to make sense of the problem in order to have an answer that makes sense. So some important information. Well, what operation is being used here? That's a good key concept to really think about. He used 1/4 a cup of sugar. If he were to pour the lemonade into 3 smaller glasses, how much sugar would be in each glass? So basically, he has something and he's kind of separating it, or in this sense, almost like dividing it up. Well, that right there should tell you that it's division. All right, he has something and he's trying to make into 3 smaller glasses, and then it says with each glass, how much would it hold? So division is what we need to do. All right, so what is being divided? Now that we know what operation, we have to think about what is being divided. So is it the 1/4 cups of sugar, or is it the 3 smaller glasses? Well, it's the 4th cups of sugar because that's what he has to make the lemonade. And then he's going to pour the lemonade into 3 smaller glasses. So we have to figure out then, how much sugar, which brings us into what? So it's 1/4 of a cup of sugar into 3 smaller glasses. And the question is, what is being asked? How much sugar would be in each glass? That's what we got to figure out. So from that, we're going to set up our problem. 1/4, because we know what's being divided. It's 1/4 cup of sugar into 3 smaller glasses. So 1/4 divided by 3. And that equals, well, let's think of our rule. Keep. So it stays at 1/4. Change your sign to a multiplication sign. And then flip. Find the reciprocal. Remember, if it's a 3, that's a whole number. So which means we put a 1 under it. And what would that be reversed, or the reciprocal? It would become 1/3. So 1/4 times 1/3 would equal 1/12. Now, you also have to remember, it's a word problem. So what is it that they're asking about? 1/12 of a cup of sugar. That is how much sugar would be in each glass. 1/12 of a cup. Now, again, notice how we broke up this word problem to make sense of it. Okay? So as always, definitely thank you, of course, for watching. Make sure to hit the thumbs up button under this video. That would be totally awesome. Greatly appreciated. And again, keep rocking this stuff out. Take your time, practice it, and just do well. All right. Until next time, take care. Bye.